to join this illustrious group. A couple more shout outs to my colleagues there. I'm noticing Dr. Miller and Dr. Burdick as well. Good to see you guys. And yeah, a little, so the title for today, Seeing the Invisible, How Chemistry Shows Us God's Love. Try to be a little interactive as we go. Maybe I'll ask a few questions. I've been teaching at Andrews since 2009 when Jason Miller started there. And then about when he left in 2012, I actually, 2009 is when he took my general chemistry class, and which is one of my main classes that I teach. I do have an upper division instrumental analysis class. But I would say about 2012, I prayed this prayer that God would help make me a chemical missionary, and that started to become clearer around that time. So it's been about 8 years. I've been trying to figure out how I can, as a chemist, be able to share about God. And is he real? Is he there? What evidence can we look to? And it's been a long journey, and I'm not sharing all of that. I'm just sharing a small glimpse, and wanting people to just to think about some of the evidence out there in a new and different way. And some of it, most of it, I would say is, well, not quite, but a lot of it's at the freshman college chemistry level, although some of it's much less than that. So don't feel like you need a chemistry degree today to be able to understand and appreciate what we're going to talk about. I do speak to young adults. I do speak to kids. I have a little nickname called Dr. Bubbles. So that's not necessarily a very academic name there, but it's kind of fun for the kids. And then I've done things for camp meetings and for adults and for churches, weekend events, to get people to see this world in a different way. And so we're going to do that. A good thing I'm wearing headphones because I can hear the cradle roll going. So to kind of launch off our little topic, I like to get warmed up and think about some of the controversies and things that people have said about faith and about science and whether they can believe in God or not. And we've heard a lot from biology and perhaps physics and things concerning the age of the universe and things about evolution and how we see things changing, and how there looks like there's evidence for animals changing into one type or the other. And really, I would say here in the last couple of decades, and for perhaps the last 100 years, but more specifically here in the last few decades, chemistry is becoming the final frontier of, I believe, this conversation of whether or not life can exist from nothing. Is there enough time? Is there enough understanding? And I really think a lot of this is becoming a chemistry problem. And there's evidence, I would say, for and against the existence of a creator in the physics field and in the biology field. There's that, but what does chemistry have to say? And I'm not going to answer all that today, but I just want to say that's where I'm trying to weigh in. I'm still trying to figure out a lot of that. I think there is some really strong evidence for the existence of a creator, an intelligent designer, and I think a little bit what we're going to talk about today gets into that. And I'd like to show a video about that, just share it, some aspects of it today. I've heard scientists and others say, I cannot believe in a God who allows all these great disasters and terrible things to take place, hurricanes and tornadoes and the bad weather, COVID and cancer. And we all know the mosquito is probably the most feared creature on the planet. And who would create such a nasty, evil creature like the mosquito? And of course, there's all the pain and suffering and other sicknesses that go on. And for many, that is enough to say, I can't believe in a God. That there's just too much pain and suffering how can there be a loving God with all of this pain and suffering that's taking place and the tragedy that's all around us? And I would say, yeah, those are all terrible, bad things. And I've seen many of those affect my family, affect me, or affect loved ones who've been hurt, who have died maybe from cancer and from tragedy and suffered loss. And I don't want to belittle any of that. There's a lot of terrible things that have happened and that are going on, as we all know. In fact, our news keeps us up to date on all the terrible things that are happening all around us. And so I hope to kind of perhaps provide some brightness and just maybe another way of looking at things that will help us appreciate that, yep, man, there is a God. And actually, he does take care of us. He does think about our well-being. And so we're going to spend a few moments thinking about that here this morning. And this scientist who went on record actually to say all these things, I just can't believe there is a loving God. And he specifically mentioned asteroids and how we never know when we're going to get hit by an asteroid and be destroyed on this planet. And so, yeah, if you focus on all these fearful things, it just does not look very good. And you could focus on that, and you could be led into a life of fear and be afraid that what happens when I step outside. I'm one step away from death. And I choose to live differently. I choose because of what I've seen in chemistry, and what I'm going to share some things with you here, that we don't have to live in fear. Yes, we need to be careful, but we don't need to live in fear, and we can recognize that there is a God. But since I brought up the comet, have you guys gone out and seen Neowise? This is my little sidetrack here. I don't know if you guys can raise your hand. Who's gone out and seen Neowise? The comet. I'm seeing head. No. All right. All right. Tonight, you guys, you're young adults. You like staying up late. You got to get outside. You can see it. This is a once in a lifetime, unless you're able to live 6,800 years, then you can see it when it comes back around again. Get out, find the Big Dipper. So I would say about 10:30 in the East Coast. I'm sorry, about 11 o'clock, and get outside and see the comet. It is awesome. You can almost see it with your naked eye. Take some binoculars. You got telescopes, good practice. Get outside and see it. Look for the Big Dipper, and then go right below it, between the Big Dipper and the horizon, about a third of the way up and a little bit to the right, whatever way that is for you guys. And we saw it on Thursday night, about 11 and 11:30. The clouds cleared up. Awesome. My kids were like in awe that they were able to see this comet. You can see the tail, and get outside and see it. It is going to be roughly 68 million miles away, so not going to hit us. So nothing to worry about there. And it's really cool. And then the photographers out there, you can play with your settings and take some really cool pictures. So get outside tonight and see this amazing thing, space object. All right, so that was my little sidetrack. All right, so since we have a fairly large group here, and let's see if anybody's in the, okay. All right, cool, all right. Okay, funny comments there. I'm going to try not to read comments there. I like to see what people are saying, but thank you for them. So this is a big, tough question, and how do we show love to each other? I'm not going to ask us to debate all the different ways we show love, but there's many ways, and I think this is its own topic, is what is love and how do we show it to each other? And it's actually one, perhaps if you haven't talked about it in this group, you should spend quite a bit of time thinking about love, because I think there's a lot of misconceptions about what love is, and then how does the Bible define it, and these sort of things. But I want to tell you that if we're looking for God and His love, one of the ways we have to think about how a father would think. And since I'm one, I have 3 kids. I have a 12-year-old, a 10-year-old, and an 8-year-old. And we went camping recently. And I can tell you as a father, one of the ways I love my kids is not to take them camping, although that is a true way to show love, is to do fun things with your kids. But to actually, well, actually, let me see if I can see some of you guys. Who's gone camping? Who's gone camping in your life? Just sort of raise your hand. Okay, we got some thumbs up. Oh, yeah, everybody's gone camping. All right, who has had a bad experience camping? Okay, a number of you. So, okay, so we had one just a few weeks ago, and we hadn't gone tent camping. Honestly, it's been about 10 years, just with the kids and not having a big tent and going off to camps, and it's been busy. So we had an opportunity to go camping half an hour north of our place here. We had an old tent. We figured it was still working. Somehow we had 2 more tents. Our kids all kind of got their own tent, and we went up on a Friday night and set up the tent outside. And we were excited. We actually practiced setting them up the night before. We're like, cool, we're all ready to go. And as Friday night rolled along, so did a huge storm. Wind, rain. The camp lady comes through. You guys button up the hatches. We've got the big storm. It's coming. We're like, oh, you know, those weather guys, they're always wrong. Well, they weren't wrong. They had been predicting for a week there was going to be a big storm Friday night, and I didn't believe them. And but it came, and the winds came, and the waters rose, and the tents leaked, and it was. I felt like I was doing a terrible job of protecting my kids, but I had a backup plan. Sleep in the van. Then we realized when we threw all of our wet stuff into the van, we're going home Friday night. So we actually jumped in the van and drove home. It was just so much rain. I felt like I did a terrible job protecting my family, but that was one of the things that I try to show to my family, that I'm protecting them. You know, good house, locked, security system. Maybe I should get a security system. You know, and we think, you know, how does God show us his love, you know, and how does he protect us? And I think chemistry does a great job of helping us to understand all the different ways that God protects us in the tent that we call Earth, this awesome place that we call Earth. And so I thought we would spend a little bit of time talking about the air, and specifically, how does God show his love by protecting us? So I'm gonna just throw it out there real quick, because I love to hear, and you can't Google this, and maybe I can't ask Dylan, because Dylan has heard my talks, but I like to hear from people. Maybe if someone wants to unmute here, be brave. What are the top 4 ingredients in our air?
Nitrogen.
Okay, all right. Jason, is that what you say? Who else? Who is that? Daniel? Did I hear?
That's
yeah,
Daniel.
nitrogen. How much of our air is nitrogen?
77%.
Ooh, that's super close. Yeah, 78. Nice, Jason. All right. Who is number 2 on the chart there? So nitrogen. So a lot of people get that wrong. I hear hydrogen. I hear all sorts of stuff. Carbon is in the air. When I ask that question, but you guys are an illustrious, elite group of smart people, I think. Right?
Oxygen.
The oxygen, very good. What's the percentage?
Like 21.
21. Very good. I like that, because if you take the 78% nitrogen and 21% oxygen, that adds up to 99%. Most of your air is those 2 ingredients. Who comes in third?
COVID.
It is. We think it's gone airborne, so you might be right, Dr. Bosman. Anyone else know the third ingredient, the third chemical by percentage in the Earth's air? Not including water. I feel like water's third right now. It's very humid, and it probably technically is. Anyone?
Carbon dioxide.
No, carbon dioxide is actually 4th. Good. That's a good answer. A lot of people actually put that one higher. No? So anyone else?
Argon.
Very good.
Hey.
Argon. Yeah, I call it argon. It is third on the list. And so we have, so you guys feel like you're back in chemistry class now? Number one on the chart, nitrogen, and oxygen, argon, and then carbon dioxide. And then here's how I remember the percentages. So I guess you just got to remember it. Argon's like 0.9%. So if you put, I think I told my son the wrong thing last night. So it's 99.9% is nitrogen, nitrogen, oxygen, argon, and then carbon dioxide is only 0.04%. 0.04%. And so 99.94% of all the air is those four ingredients. And then water can go up to 4%. When they say it's 100% humidity, they mean it's kind of reaching its maximum of 4% in the air. So we have all of these different types of ingredients, the different ratios that are there. You guys are doing good. Okay. So the thing you got to think about when you're worried about gases, which is what our atmosphere is, you can think about the different types, just like, you know, a box of crayons. You can have all the different types of crayons. We can have all these different types of gases in our air, but you can also have different a total amount, right? Oh, I was so excited to try to get the 64 pack of crayons when I was younger, because they had way more crayons than those lousy 24 packs. And so you can have the same ratio of blues, reds, and yellows as you could, you know, in a small pack or a large pack. So we think about those things. Those are like two major aspects when it comes to our air. We could have the different amounts, but then you have different total amounts. So hopefully you guys can see that on the screen. I don't know if where your little bars are. So you can see the numbers there. And we say all the weight of these things adds up to 1 atmosphere. Well, just to contrast that, we'll go with our sister planet here, Venus, which is at, it weighs a total, so there's a lot more crayons or gases in total weight on Venus, 92 times heavier than our atmosphere. But it's made up of carbon dioxide and nitrogen. And you can see the numbers there, 96% carbon dioxide, 3.5% nitrogen. Now I have a talk, I gotta tell you, for each one of these things, for nitrogen, for oxygen, carbon dioxide, ozone, and other gases. We're not gonna do that today. That's not our purpose, that's not our goal, but just, I want you to know this gets deep and it's awesome. And, but we're going to focus in on what does the air do for us in terms of protecting us. And I wanted to see if we could come up with, as a group, 10 ways that the Earth's air protects life, which is us, but also other creatures and living organisms. And it's a fun thing, and perhaps an eye-opening way. We often just think of the air as oxygen, and it keeps us alive. But if we see the protective role that it takes, we may step outside and take a deep breath of air and be a little bit more appreciative of what God has done. So I'm going to go back to gallery view here so I can see some people. If someone could unmute and think of a way that the Earth's air protects us from something. And maybe you could describe maybe why, if you know. I don't know. And then I can go into a little more detail. One thing. Who would like to go? Is that Dominique?
I guess for one would be doesn't protect us from UV rays.
Okay, so is that Jamal? Is that what you said? UV rays? Okay, we'll go with that. Nice. And then Dominique, did you have one?
Yeah, that was what I was gonna say. I guess
Okay.
it was like ozone. Yeah, right.
That's right. The ozone, and actually the oxygen and nitrogen. I have lots of charts to show all these things, but they block us from the. The sun isn't just producing UV and visible light. It produces all the different parts of the spectrum: X-rays, gamma rays, and then radio waves and other aspects of the microwaves and all of that. Now it's mainly visible, and it's and then slightly less in terms of UV. And I was going to do a little thing. And so, well, we'll get to oxygen in just a second. And so, yes, and so it is protecting us from different parts of the electromagnetic spectrum that are very dangerous. So if we're getting some protection from the ultraviolet light, we're getting a lot of protection from gamma rays and X-rays. They put to shame UV. I mean, those things will kill you quick if we were to get exposed to that from the sun. So yes, our air is like a big umbrella that is protecting us from the solar radiation that's coming from the sun. Now, does the sun spit out anything else besides just parts of the electromagnetic spectrum? Does it do anything else, you guys?
Lots of electrons and protons come out from the sun.
That's right. Very good. So there is a solar wind. So there's particles on top of all the light or the energy stuff that's coming. And our air plays a role in protecting us from that. I would say when I talk about the air, it's not just solely the air. There's other features, which makes it even cooler, that we have a magnetic field that's deflecting lots of that. And then all these particles have to try to get through the Earth's atmosphere. And that's a big challenge. So I would say our Earth is really, the Earth's atmosphere is doing a lot to protect us from this big nasty out in outer space, the sun. Now we need the sun, right? We need the light and the heat there. All right, awesome. Okay, now I have on my screen here, while you guys are thinking some other ways that we're being protected, I thought I would just take a moment here, a slight sidetrack, and tell you about oxygen. And so yes, we have to have oxygen and we have to have it alive. And I was actually looking to see if I had a 4-leaf clover on there, but that's not the distraction. As I've been searching for, where could our oxygen on our planet come from? When I say oxygen, I mean O2, the diatomic molecule that we breathe that sustains us, that sustains all living creatures that use oxygen. That this is what they use. And as far as I can tell from reading a number of books and trying to research this, there is not what I would call a natural way, and I'm choosing my words carefully here, to make oxygen on a planet. If there's going to be oxygen on a planet, the oxygen, as far as we know, can only be generated from plants. There's not a way to use very easily to use heat and light and rocks. The oxygen just binds too strongly to other elements, and to have it free up as an O2 is a huge thermodynamic challenge. And plants have mastered this, or they were designed to do this. So to find oxygen on a planet is very rare. And some may shout out, well, Mercury has a little oxygen, and that is right. Mercury has very little oxygen. There's a tiny, 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 tiny amount that's there. It's very hard to oxygenate a planet. You have to use plants if you want to maintain it and get out there. So that's something I've found quite interesting here. And then one last thing here, I would say protection comes in a number of forms. One is, as we've kind of talked about, you're trying to block the thing from, it's coming towards us. And sometimes, so I have this nails on the board here, and I know as a parent, I see that nails on the board, I'm like, my kids are going to step on that, or I'm going to step on that. I want to get rid of that. And so we move those aside. So sometimes the danger we can be protected is just to get rid of it, ahead of time and just not to have it there. All right, so I'm going to go back to gallery view. Has anyone thought of any other things that our air does to protect us?
Yeah.
All right, is that Daniel? I'm seeing
it is.
Okay, good.
Keeping with the theme of stopping things from reaching us, I think mechanically the atmosphere through friction destroys a lot of projectiles that would otherwise reach us, at least a smaller one.
That's correct. It does a lot. Very good. So the friction, yep. The more air you have, the more friction it would have. But we have just enough to burn up practically everything that comes our way. In terms of asteroids, the rocks, the space debris that come our way. There's a lot of space debris that hits us every day. even, and gets disintegrated and doesn't even make the news. And so it just falls into your house and under the ground. And that's why things are always dusty. I mean, the wind's blowing dust around, but then the debris. So if you wonder why your apartment's dusty, you can blame the air blowing stuff around, but disintegrating space debris. All right, so very good. So I think we've got at least 2 good ones. There's a practice from the sun and at least a couple different ways from, what else?
I would also say it makes a thermal blanket, protecting us from extremes in temperatures. So while it does filter out some types of light, it also, because of the composition, is able to keep the heat from just leaving.
That's right. Very good. So I don't know. Okay, I'm going to stop sharing this for a second and get into a different view here, because I wanted to be in presenter view. And so we did solar radiation. Okay. All right. Sorry about that, folks. Share screen, because I had a fun little one on Dylan's comment here. So we had solar radiation that's protecting us from, and then I wanted to make a comment here. Here we go. So our air does a great job of keeping us warm. Now we see the protest, and we're also worried about global warming, but we actually need the air to keep us warm. If we did not have carbon dioxide in our air and some of the other gases that cause global warming, the average temperature on Earth would be a minus 20 degrees Celsius. Last time I checked, that's cold, and we would have a lot of things freezing. So I would say that global warming is important. So we don't want to stop global warming. We want to stop excessive global warming. So that was kind of hard to fit on their sign, I'm sure. So our protesters here should probably add that word. We actually need global warming. We just don't want too much of it. All right, very good. So I took the liberty of adjusting their thing. So very good, Dylan. So we've got, so there's protection from extreme cold and extreme heat. We get that from our air. What else? Might be getting into the weeds here a little bit, but does anybody think of something else? So if you're designing an atmosphere, you have to think about all these. You got to put the right gases in to make sure it doesn't get too warm, too cold, enough to protect from random space debris, solar radiation, all types, the electromagnetic, the particles, all this stuff that's coming. Maybe I'll just go through my list here. Does anybody
Our body needs a certain amount of pressure to keep us from exploding outward.
Ooh, yes, that's very good. I'll touch upon that one. Yes, that's right. We need this balance and pressure, and that's going to tie into one other thing. Very nice, Nicholas. Anything else?
I would say this is maybe a bit of a stretch, but you need an atmosphere that will be able to transport nutrients. So I think like the water cycle, for example, you need a system that's going to be able to get the moisture to areas that need it, and without a difference in the atmosphere's composition, you would not get current flow, and therefore you get areas of stagnation.
Very good. We definitely need the movement, and that has to do with the thermal stuff. So maybe I'll just run through a couple of different things here because I know we need to kind of wrap it up and then maybe have some discussion here. So nice, Dylan. Nice. You guys are doing great. You're putting this all together. Our Earth, you could practically go anywhere on Earth except for extreme heights and there's certain places. But you pretty much have oxygen in so many places on Earth. And so why that's important is there's other gases that are very heavy that could push oxygen out and away and up, and we do not have that problem. And so not all gases mix well with oxygen. Some can sink lower and push it away. And so we are protected from not having the lack of oxygen. We always will have enough. We could just say whether that's from the plants, from the other gases, not pushing it out of the way. We talked about the radiation from the sun, but our Earth is actually very radioactive. And the air itself blocks a lot of that's coming up from the earth. It's a whole nother topic. And so it doesn't block all of that, but it blocks quite a bit of alpha particles and beta particles. They really slow down just by going through the air. So we got to be thankful for that. And then why did God make the planet radioactive? Whole nother talk. This kind of ties in with what I've heard here about moving things. Life from falling, and we've got birds that can move around and nutrients and other things. But when scientists are trying to land things on Mars, they can't. Mars has about 100 times less the atmosphere that we do. And so they can only do so much for landing things. But you can parachute, birds can fly, seeds float. And so there's this whole movement that can take place in the air because we have enough of it. So I'm kind of taking a little liberties here. Life protects life from falling, but this is partly this is true, I think. Protects us from speed. Now, some of you may just say this is a gravity thing, but it's earth and gravity. The air creates friction, which slows things down, and on top of our gravity. And so you put these things together, and if you think about movement, you really want to have enough resistance so you can slow down. And if we think about outer space and astronauts and things, if you get going off and you're not tethered, you won't stop. And there's nothing to slow you down. And so I'm thankful for our air that it actually provides some resistance. Now, if you're trying to go fast, that's not necessarily a good thing. And I would also say that our air is very good at allowing sound waves to go through there so we can communicate with each other. And communication allows us from spontaneous dangers that arise. So I think the communication aspects of it, we can talk, we can, and our words go through there. There are other gases that are very dangerous that our Earth is designed to protect us from. This is where I would normally go to a demonstration here. Anthony, how are we doing on time?
You can go ahead and take a few more minutes.
Okay, just a couple more
groups.
Yeah, we're about ready to wrap it up. But I've got a video here, so let's see if I can share this. Share computer sound, and let's see if this will work. There's some other dangerous gases out there, and that's funny. I practiced these things and it was working last night. I'd have to show it separately, which I may do, and I may just try to find this one here. I don't know. Sorry, guys. I don't know why. I don't know if anyone has this problem. PowerPoint, it works great, and then I actually go to do it. It may be, oh, you know what? I think sometimes it has a problem sharing video and Zoom at the same time. So I think that may be what I'm running into here. So I am just going to go back, and I will just tell you. Oh, I see some good questions in there, but I'm just going to finish. I'm almost done with my protections here. And so there's other gases like hydrogen gas, which are very explosive. And hydrogen has a lower density, so it actually floats. And because Earth's gravity is not enough, and so it's a combination of the gases plus gravity, that hydrogen leaves, and it would explode with the oxygen that we have here on this planet. So there's other gases that are very dangerous and toxic to life. We don't have them, or we have very little of these gases. Carbon monoxide, to name one, hydrocyanic acid. There's others that are found on other planets, but we don't have them here. We talked about the friction already and how we have enough air to provide friction that protects us from space debris. And then I'm going to end up with some of just combining all of these thoughts that we've seen, that our air provides enough weight to hold water as a liquid. And the air pressure sets the boiling point. And if we had less air, water would boil very easily. It would turn to steam, and steam is definitely, and water vapor is a huge greenhouse gas. And so, our air plays a huge role in setting the boiling point and dictating the water cycle. So you have to think about all of these things. If you're going to build a planet with life and protect it, you want to put all these things in. And this is what God was thinking about, I believe, on day 2 in the creation story, that when he separated the waters above from the waters below, putting in the air, creating liquid water and our atmosphere. So there's at least 10 things. You may think of more, and we could break those into different aspects as well of God showing us love. So when you think of air, it's not just trying to keep us alive with oxygen, sure, but you're also trying to prevent some of the bad gases from being here, from the radiation and other dangers. And so you can't just have oxygen on a planet, you got to have all of these. And I would argue that the ratio is extremely important as well. And so I would say when you see a planet that can house life, we see that that has to come from, I think it comes from a design, and I can show that in a lot more detail. I'm just not here to do that today, and how what the planet we live in is actually not that natural. So I believe we need a new look at the things that our world is made of, and from chemistry, that if we tend to overlook things, pun intended, we overlook the air because we can't see it, but by focusing on some of these things and their purpose for life, we will actually see God in new ways. And so I hope you will appreciate that. And I'm just going to end with this psalm right here. I will lift my eyes up into the hills, Psalms 121. Where does my help come from? My help comes from the Lord who made heaven and earth. David reiterating our creator here. He will not allow your foot to be moved. He who keeps you will not slumber. Behold, he who keeps Israel shall neither slumber nor sleep. The Lord is your keeper. The Lord is your shade. At your right hand, the sun shall not strike you by day, nor the moon by night. The Lord shall preserve you from all evil. He shall preserve your soul. The Lord shall preserve your going out and your coming forth in this time forth. And so I'm just appreciative here that David kind of encapsulated a lot of what one thinks about when you're trying to protect the world. And so I shall leave it at that point, and say that the deeper I get into thinking about how things work on a chemical basis, I actually see God's hand at work. And I'm happy to take questions or do what you guys are going to do next.
So I have a question. I was kind of curious. I was honestly surprised that argon was kind of the third, most plentiful air in our atmosphere. Granted, it's a tiny percentage, but it's there. And I was kind of wondering, what does it do? Like, is there any kind of purpose for that argon? Because oxygen, obviously, we breathe it. Nitrogen is, I think it's important for different plants and other other life on Earth. But is there anything that argon does specifically that contributes to life?
That's a great question, Kara. Of course, that's one that I love as a chemist. I've looked at that a little bit. I would say this: argon. You got a couple of things. Argon comes from one of the sources could be the radioactive earth. Actually, one of the radiometric processes spits out argon. So it's possible that why we have it is from some of these radiometric processes, radioactive processes. Why is it there? I think it does add some weight, which improves the friction of things burning up. I think that's part. But it is can be a very dangerous gas. Dangerous in what way? Well, you can breathe it. It's not going to kill you. It's not oxygen, so you can't breathe it for too long. But it's a heavy gas. And as chemists, one of the ways we've used argon in the lab is if we have a flask, and if we want to get rid of the oxygen in the flask, but that's kind of hard to do. It's like taking a flask under the water and saying, how do you get rid of the water? And you're under the water. So if you're in oxygen, how do you get rid of oxygen? Well, if you have a tank of argon, it is heavy enough that if you put it in there, it will fill up the flask and push the oxygen out. So if you're going to have argon on your planet, if it has a purpose, it can't be too much, because it will push the oxygen away from the ground, and it would kill low-lying organisms, and if it's deep enough, it would kill people. So thankfully, it doesn't. There's not a whole lot of it. Argon's not reactive. It doesn't react with anything, so it's not really used for any chemical purposes. It doesn't block radiation very well. Noble gases do not. They're not good at blocking the solar radiation. They don't have the chemical structure that absorbs radiation very well. It's very narrow bands of absorption. So I honestly, living systems don't use it for anything. So the only thing I would go back to is it may have something to do with the weight of the atmosphere and how it plays into the boiling point of water and some of those things in protection and friction. Why is it at that level? I don't know. I think it's worth digging into, and that's the right question. What's it there for? And that's about all I could say at this point about it.
Awesome, thank you.
Mm-hmm.
Yeah, and I think just another idea, argon doesn't do this as much, but you also don't want too much oxygen. I don't think argon does this as much as, say, nitrogen, but if you have too much oxygen, then combustion becomes way too easy, and you don't want that either. So I think another dynamic of these questions is making sure you get the right ratios of elements and gases.
Jason, you highlighted that there are some comments or things in the chat, and I took a look at those here about where did oxygen come from. And I know I simply put it as plants, but it's really living organisms using photosynthesis is really the genesis of oxygen on our planet, or this is how our planet maintains its oxygen levels. The evolutionary story, I think, is pretty close to what was described in our chat here, that life started as some living systems, bacteria, small cyanobacteria that lived in the oceans near thermal vents. The thermal vents did not actually produce oxygen. They produced sulfur compounds. Oxygen from our air, through an amazing process called the grand conveyor belt, actually, and cold water and hot water are able to mix oxygen O2 down to the low levels to actually neutralize some of the dangerous gases that come out of the hydrothermal vents. If life got started down there, maybe so. This is what the evolutionary theory is proposing. I would propose that they are not looking at. This goes back to the origins question. How did life get started on this planet? What does it need? And this may be actually a great segue into, we're actually going to have a speaker, a Zoom speaker in September, Dr. James Tour. He's not a Seventh-day Adventist, he's a Christian. He teaches at Rice University in Houston, Texas. And he has come out quite adamantly as one of the leading organic chemistry teachers, researchers in the world. He's also a nanotechnologist. He basically means he knows how to manipulate chemicals at the nano scale, which is actually a large scale for most chemists. And he is adamant that we just have no clue how life got started. We don't know the chemistry. We don't know, we basically, as much as we know about chemistry, and we know a lot, we don't know everything, but we just, scientists really, if they say anything about, we know how life went from this molecule to that molecule, and then we finally got life, they're wrong. We simply do not know from a step-to-step process. And this gentleman has agreed to give us a talk at Andrews that we're going to broadcast on Zoom. And I'd like to get 500 people or more to listen in on that talk. And so when we say, or when we hear life got started at hydrothermal events, well, what's life? What's the simplest organism look like? The simplest organism we know, like a bacteria, is thousands of chemicals coming together. Many of those are enzymes and proteins, are very complex structures that need to come together, all at the same time, in the same place, in a way that allows them to coexist together all in the same place. Thousands of chemicals. And many of those chemicals, like enzymes and proteins, have to be created by a living system. So how does a living system create all the right things in order for a living system to come along? There's a lot of chemical conundrums that take place when you start looking at the first living system. And James Tour is advancing, or at least trying to tell the world, look, we don't know. We are so far away from understanding any of those steps where life could have started from. And I would argue that it's statistically impossible to bring thousands, 3,000 to 4,000 different chemicals. Maybe it's a smaller set, even if it was 1,000 different chemicals that need to come together to form the first living systems. That is statistically impossible, let alone, and we're not even looking at the thermodynamics and concentrations and whether these chemicals last. It is, so we can throw out that yeah, I mean, it's easy to throw out as a biologist to say this bacteria and that one became that. But when you look at it from a chemical perspective, the enzymes and the systems that are needed are complex or require engineering to bring them together, and to do it reproducibly is an amazing feat of systems and chemical systems coming together. So the chemical origins. So I can go off on that, but I don't want to do that too much.
I'm thrilled to hear this, Ryan. I didn't realize you had secured him. I'm a huge James Tour fan, being a Rice alum, but also he's just a real distinguished researcher. He's been named Scientist of the Year, a number of awards and accolades. But just hearing him present with his a clear authority in the field, right?
Absolutely.
As someone who is a synthetic chemist who has a job of making various nanotechnology right now, you can come out and say, I know how hard it is to create chemistry, right? So it's fantastic that we have him, and I'll be sure to advertise that in this group. And I'm sure many of us will enjoy that.
So I mean, I resonate with him because I feel like I actually gave a talk and managed a symposium that he was a part of when I was a grad student. So his area and my area have overlapped over the years. And I think when you actually try to do chemistry, it's hard. It's hard. It doesn't work out. There are so many forces that mess things up. And I just feel like other disciplines don't have that appreciation, honestly, that you have to get in and make something. And those of us who have gone in and try to make things, you know, it's like going, you know, it's someone who's made a cake and made cookies and these things. You know, and you're talking to, you know, people who haven't. It just isn't the same appreciation for the, you know, what's, you know, putting all these ingredients together.
Yeah, and you don't just have to make a cake, you have to make a reproducible cake.
Amen. That's exactly right. Right, on its own, automated, an automated self-reproducing cake. Just go do that. Come back.
And I would also
That's your
argue,
assignment.
it's a self-correcting system, because we know that our DNA is constantly being damaged or altered, and what many people don't realize is the body actually has mechanisms to repair some. Not all of them get repaired, and that's why we have mutations. But if we didn't have those mechanisms, we'd see a lot more mutations.
Absolutely. Yeah, Dylan, you hit on the head. You guys you're hitting some of these. I think the chemical, you know, if you have something that's broken, that's a whole nother talk. You gotta know how to you can't just fix it. You can't wave a wand and fix it. I'm trying to fix my house this summer. Oh, this is terrible. Don't buy a house, you guys. Wait, who bought a house here recently? Anybody? Dr. Bosman? Anthony, I think, bought one. Yeah. Have fun, man. We're always a slave to our home unless you're able to buy a nice house, which I was unable to do. So I got stucco problems and cement problems and a lot of, I mean, things are always being torn down, and I have to put all this energy and thought to try to fix it. Repair is a key sign of intelligence coming in and fixing it. Very good. Any other questions?
So kind of going off that idea of James Tour, you know, his idea that we don't know, should we give in to despair about figuring out the origins of life? Is there any point in trying to examine this question? Or
Yes.
like, what is the value of continuing to explore it is kind of my question.
Yeah, that's a great question. And a number of people, I personally, the more we know, the better, right? I mean, the simple argument of the more we know, the more that information could help in various other things with disease, with, health related things, and with fundamental science. So I think there's just a fundamental science issue there. There's currently fundings for it. So if you're looking to get funded as a scientist, there's money out there, not too much, but National Science Foundation is in NASA, and some other systems have come together to fund the chemistry of the origins of life. So I honestly, I mean, I love it. Go research it. Go figure it out. Let's help us to understand all the chemical systems that have to come together in order for life to happen, and will give us a greater appreciation for what life is. All for it.
Maybe we have time for one last question. If there's someone who wants to do one last question, then I'll ask Brian if you want to close us out in prayer, maybe after one more question.
Yeah.
What your presentation reminded me of this really short quote from Steps to Christ. It says, "In the matchless gift of his son, God has encircled the whole world with an atmosphere of grace as real as the air which circulates around the globe."
Awesome.
And I think at school how like God's given us all these metaphors of himself, but a lot of times we just have a superficial understanding of whatever the metaphor is about. So it's awesome how science can help expand our appreciation of the metaphors.
We need to stop there. That was perfect. Elise, thank you. That is a great quote. And I will end us in prayer after that. We couldn't send it any better. Thank you so much for bringing that quote. I need to pull in. Mrs. White has some awesome things that relate and bring these things together. So thank you so much. Let's pray. Father God, I thank you for this illustrious group of Zoomers that we could talk from around the world and interact with each other and share our passions and our questions. And Lord, thank you for being real. You're as real as the air. And for many people, they miss that. They miss your presence that's all around us. And may we just take a deep breath today many times and appreciate your design and your love and your care and your protection for us. And Lord, let us not be ashamed that we follow you. And when others seek you with all their heart, they will find you. And as we are trying to do. So I pray a blessing on this group and on all these people and the various things that you have blessed them with, talents and the people that they talk to and groups they interact with. And may they be a shining lights in their community. Thank you for our time together, and we praise you and thank you in Jesus' name. Amen.